Okay, so I have gotten a couple of questions since after class um, from 2, 3, 4 persons, and it's about this particular question. Somehow we skipped it during our class, so I want to kind of answer it here so that you get clarity about it. Okay, so this question here says that the amount of calories consumed by customers at a Chinese buffet is normally distributed with a mean of 2849, a standard deviation of 700. Say one randomly selected customer. Okay, so we have all that. X is the random variable. We need our answer in 4 decimal places. And the question of interest is if there is an award to be given to 3% of customers who consume the most calories, right? What is the fewest number of calories a person must consume to receive that award, right? Okay, so pay attention to the key thing here, and I'm going to underline that in red. The key, so the key expression here is most calories. So this is kind of fundamental to the answer to this question. So let's sketch our usual normal curve. So if this is the sketch of the normal curve, you are looking at 3% at the most, right? So if you're starting, remember this goes from 0 here all the way, sorry, not 0. So this is increasing this way, right? So it starts from the least over here and increases to the most here. So that when we're talking about the most 3%, you're talking about the 3% that is up at this end. This is the most 3%. So everybody who falls into the shaded area, or whose numbers of calories falls into the shaded area, will receive the award. So your interest is the number here. The number of calories are these red dots, okay? So if we know that this is 3%, let me move back to black. If we know that this is 3%, okay, so we're looking for the number of dots here, but so first you're going to use the table, and so you have to find the Z value that is equivalent to this first, right? And then when you get the Z value, you convert to calories. So but first, let's look for the Z value, right? We're going to be using the table, but remember, as we've said over and over again, that the table shows you a computation of area from the left tail. Okay, so if I go to the table to look for this value of this Z here, what I'm going to get is the area on green, okay? Because the table is, left cumulated. So it's cumulated from the left tail towards the right. Okay, so the area on green here will be 97%. Because if the area on red is 3%, then the area on green must be 97%. So when I go to the table, I'm not going to be looking for 3% because the table shows me the value from the left tail. So I'm going to look for 97%. Okay, so 97% of course is equivalent to 0.97. So I'm going to be looking for this area on the table. And with this area in the table, I'll be able to find equivalent Z-score that marks that cutoff. So let's go to the table now. I think I should have one pulled up somewhere over here. So that is your table, right? So I'm looking for the area 0.97 is definitely positive. So we're going to look for that. This is 97 over here, or 977 over there. So 97 is over here, but this is big, of course. I'm going to go down looking for a smaller value. We'll come to this row. So this is 97 here, the closest to 97, but it's slightly bigger. So as we've been doing, we're going to take the conservative value, the one slightly smaller. So I think I should color this. Let me color that. So we're picking up this. Let's highlight it to yellow. Okay, so the highlighted is the closest. So if you trace that here, that gives you the Z-score of 1.8, and if you go up, it's also on the column of 0.08, right? So that means my Z-score for this question Something is popping up here, blocking my view. Okay, so that means the z-score for this question would be 1.88. Okay, so let's go back to our question and complete the work. So now we have that this z value over here is equivalent to, let me change to black, is equivalent to 1.88. So this z value over here is equivalent to 1.88. Okay, so, but that is the z value that's equivalent to the calorie of interest. So you're going to use the formula to convert it back to calorie, the usual formula. So our z here is given as beta minus the mean divided by standard deviation. Okay, if you plug in values here, excuse me, you plug in the values here, of course, your z is 1.88 is equal to your data is the amount of calories you're interested in. The mean in this question is 2849 and the standard deviation is 700. So this is 2849, the standard deviation is 700, right? So of course, if you work this out the way we've been doing, that gives you xi will be 1.88 times 700. Okay, plus 2849. Okay, so I have a calculator here somewhere. I'll pick it up and make sure I have an actual final answer. Okay, somehow I can't find it. Okay, there it is. So we do 1.88. I can actually do it over here, so you can see that. Okay, so we would do 1.88, right? Multiplied by 700, right? And that gives us this value over here, 1,700 plus the mean, which is 2849, right? So that gives you 4,164. Okay, so the answer to this question then is 4,160. Is that 4,164? It's 4,165 calories. Okay, so 4,165 calories is the least amount of calories that will be consumed for the person to get this award. So here, the z value that's equivalent to this in terms of calories is 4,165, right? So anybody who consumes at least this amount or anything more than that gets the award in this question. So I hope this is helpful, and let me know if you have any other question. Keep working hard on this and focus on understanding the concepts. That is what will help you on the midterm. Okay, I'm going to share this with you now. All right, bye.